Everybody. This video is basically a preamble before I start making a series of videos on solving quadratic equations by completing the square. Whenever you're solving quadratic equations, or really whenever you're doing anything in math, there's a little bit of work that you might have to do in the middle of a problem. So one of the things that you have to be aware of is anytime you encounter a square root, like let's say the square root of 40, it's perfectly fine to encounter a number like this, and it's perfectly fine to write it down. However, when you proceed to the next step, you always want to simplify your roots. Now, the way I would simplify the square root of 40 is I would say, well, I know that 40 is 4 times 10. And since 4 is a perfect square, the square root of 4 is 2. So the square root of 40 simplifies to 2 times the square root of, I don't know why I wrote the number 5. I think I was thinking about the factors. 2 times the square root of 10. I can't do anything with the 10 because 10 is 2 times 5. There's nothing I can simplify. There's no perfect square. Now, I was able to do that because 40 is a fairly small number. It has very nice factors. Well, what if you have a number that's a little bit larger? Okay, let's say you had the square root of, I don't know, 72. Well, 72, if you break this all the way down to its prime factors, 72 is, and you can make a factor tree on a piece of scratch paper or something like that, but 72 is 2 times 2 times 2 times 3 times 3. So the way this works, if we're not going to think about perfect squares like we did in the first problem, is you want to look for 2 copies of any factor. So I have 2 copies of the number 2, and I have 2 copies of the number 3. Well, if I have 2 copies of one of these numbers, well, 2 times 2 is 4, and then when I take the square root, I get back to 2. In the same way, 3 times 3 is 9, and when I take the square root, I get back to 3. So, when I have 2 copies of a number underneath the root, it can come outside as a single copy. In the same way, a single copy of 3 comes out of the root, and then I'm left with a single 2 underneath. Well, since I brought out a 2 and a 3, 2 times 3 is 6. Now, it would have been faster to go back to the beginning of this problem and just say, well, I know that 72 is 36 times 2, and the square root of 36 is 6. But depending on the size of this number, you may not be able to spot these perfect squares in your head. So however you do this is fine. In the example in blue, do it in your head, look for perfect squares. As the size of the number increases, you may have to break it all the way down into its prime factors, looking for 2 copies. So that's how you simplify roots. Now, rationalizing denominators. Again, this is just something that shows up in the middle of your algebra problems, and you have to be aware of how to deal with it. So you might be in the middle of an algebra problem, and you're doing your algebra, and you end up looking at this number, 5 divided by the square root of 3. Well, for several reasons that I won't get into in this video, we don't like having irrational numbers, or in particular roots, in the denominator of a fraction. So we don't want to see roots in the denominator of a fraction. And we use a process called rationalizing the denominator. Now, don't just see this as random words on the screen. We have an irrational number in the denominator, and this process is going to allow us to turn the denominator from an irrational number to a rational number. So we're going to rationalize the denominator. And here's the trick for doing it. All you do is you multiply by whatever this root is, and that'll do the trick. Now, you're not just allowed to multiply by the square root of 3 because you feel like it, so you also have to multiply by the square root of 3 in the numerator. So what we're doing in green is we're multiplying by 1, and that's certainly allowed. But the effect that this has is in the numerator, we have 5 times the square root of 3, and in the denominator, root 3 times root 3 is 3. Now, just a caution, the number 9 doesn't need to cross your mind here. Yeah, 3 times 3 is 9, and when you take the square root, you get back to 3. But the number 9 doesn't really matter. If you have the same root multiplied by itself, you get whatever that number is. And not thinking about the number 9 can just save you a couple of seconds when you're doing arithmetic. So let's do one more example of that. Let's see. Let's do 6 root 5 divided by root 2. Now, the 6 and 2 does not cancel. A lot of students would like to cancel them. Long story short, numbers that are inside of roots, numbers that are outside of roots don't play nice together. So just like in the previous example, we have a root in the denominator, and we would like that to go away. And it's exactly the same trick. We multiply by the square root of 2 in the denominator and in the numerator. So we're multiplying by 1. That's certainly allowed. So let's see what happens here. I'm going to write down the 6. The square root of 5 times the square root of 2 is the square root of 10. Now you can look at the previous examples. The square root of 10 does not simplify because it's 2 times 5. In the denominator, again, the number 4 does not need to cross your mind. The square root of 2 times the square root of 2 is 2. Now, we do have one more step here. The 6 and the 2, they do cancel. Remember, numbers outside of roots and numbers inside of roots do not play nice together. But the 6 and the 2, neither one of those are in a root. They work just like any number you're used to. So 6 divided by 2 is 3, and our original number simplifies to 3 times the square root of 10. So these two techniques, simplifying roots and rationalizing denominators, there's something that you'll have to deal with in any class where you're ever working with roots. Anyway, hope this helps.